APS3 Measurements of Electrical Variables.
This practice analyzes a DC resistive circuit using theory, simulation, and a real protoboard, set up with the goal to compare three methods and understand how electrical variables behave in real conditions.
Circuit under study.
The circuit uses a 15-volt source and 6 resistors arranged in a mixed series parallel configuration. This design lets us observe different voltage drops and current paths across the network.
To start, we're gonna do a theoretical analysis in order to figure the electrical behavior of all the components inside the circuit, all the voltage drops and current values, using Kirchhoff's laws and the Ohm's law.
To perform the theoretical analysis, the mesh method was used, so 3 meshes were first identified and assigning the current to each mesh in a clockwise direction. We did the analysis with the short method, which is the sum of all resistances in the mesh multiplied by the current of that mesh minus the resistance that is shared with another mesh multiplied by the current of the mesh with which is shared, and so on until there are no more shared resistances. Then equalize to the number of volts that mesh has. In case the voltage is not available, it equals it to 0, and then all this divided by 1 kilo to obtain the units, which are in milliamperes. By doing this with each mesh, in this case there would be 3 equations to solve by a system of equations, resulting in a current of 0.95 milliamps for current 1 and 0.34 milliamps for current 2 and 3. Knowing this, you can obtain each voltage in each resistor by assigning signs to the resistors so that the voltage of that resistor is the current that enters the resistor through the positive, minus the current that opposes multiplied by the kiloohms of the resistor, thus giving the unit of volts. Finally, to obtain the current in that resistance, subtract the current that enters through the positive assigned to the resistance minus the current that opposes. Following the steps for the current and voltage calculations already mentioned, the results shown in the following table were obtained.
The next step is the simulation of the circuit. The circuit was built in the Tinkercad simulator to verify the previous analysis. The voltage and current were measured at the same nodes and components as in the calculations. For each one of the components, their voltage and current were measured to verify the theoretical analysis that was previously done. These are the simulation results. Now we will continue with the implementation.
We used a power supply, a protoboard, a multimeter, jumper wires, and the required resistors. This equipment allowed us to safely build the circuit and take accurate measurements.
So now, for the real implementation, we built the circuit on a protoboard, as you can see in the images. Then, we used the power supply to give the circuit 15 volts. So, then we could use the multimeters to measure currents and voltages and then compare them with our other results. In this slide, you can see the photos of our measurements. Finally, in this slide, you can see all our measurements, starting with the 18k ohms resistor with 0.61 milliamperes and 10.2 volts, passing through the 6.8 ohms resistor with also 0.61 milliamperes and 4.2 volts, and then we can continue on and on.
By combining theoretical mesh analysis, the Tinkercad simulation, and the real measurements, we confirm how the circuit behaves.
But even with this and the similarities that all the models that we created had, some discrepancies were noted inside these models. This mainly happened in the implementation of the circuit, but this can be explained with the fact that the resistances that were used had little variations between the ones of the ideal circuit and the ones that were used. By considering this, we can see that all the analysis gave us almost the same results.
All the 3 approaches were very consistent, proving that our calculations were correct. This activity helped us to understand resistive circuits more deeply and to improve our measurement and our analysis skills.
Thank you for your attention.